I don't think you're live yet.
I'm
Starting soon,
starting
okay.
like in this second. I started a few seconds ago.
Okay, sure. I'll just live redirect. Yeah, you can see it here. There's this live redirect option. And yeah, so you can just...
Good to know.
Wait a minute. Can I only redirect to my own videos?
Maybe.
Okay, so I'll just...
I thought that, well, it doesn't matter much. Just, you guys, you can go to Twitch, Eric Tower. Just in Codeforces, there's a link now.
Okay, I can't. That's fine.
3.
I'll just put this in the chat here. And I'll print pin this so that people can go there. Okay.
All right.
Cool.
Thanks for having me.
So thanks for coming, and goodbye.
See ya. Bye.
Okay.
All right. So back to, I guess now back to my stream. Now let's move to my stream. I was now the guest on this channel, YouTube Demoralizer. We talked about solutions for Codeforces contest. I will paste a link to his channel in Twitch chat if you aren't aware of him. Demoralizer now has a different Codeforces nickname, like Healthy UG. I don't know what that means. Hi everybody in the chat. John Weem, John Go, Viju, Ken, Thunder Aldo, Lakshay, Sanim. Hi. So we covered this Codeforces round, or at least hard problems from there. We mainly talked about F. And now let's solve some easier problems of difficulty around 1600, 1800. We already talked about something of magnitude 2500 at least. Hi everybody. Okay, what are we doing? And Discord ping. Oh. Stream pings. Everybody's okay with the sound? I hope I didn't mess anything up by the meeting with Demoralizer, but it seems that it is working. Problem set. Maximum width, that's maybe a good warm-up problem. I can do those too, unless something is very stupid, annoying, stuff like that. Hi Flipper, Ahmed, Sandeep, hi, welcome. Two strings S and T. Sequence is called beautiful if the corresponding characters match. Width of a sequence is defined as maximum difference. Maximum width. Should we just take two elements? Smallest width might be an interesting problem. It's like kind of longest common subsequence, but different. So is it true that I will just take... Oh, no, not really that. I thought that we should just focus on two characters, but that's not entirely true. Almost true. If we are looking for ABC in this one, then I'm looking for AB that are far away from each other, and I can still finish this, right? Link is not updated. Thank you. Link. Where is link? I don't see it. Oh, here. Oh. I'm blind apparently. Okay. Maximum width problem. It's just a warm-up, then we move to something a little bit harder. The two easy problems, and then something harder. If I'm looking for ABC in this longer string, then, or let's say ABCD, then it's fine to take BC that are far away from each other, let's say here B, here C, as long as I can finish this string. So there is D on the right and there is A on the left. So maybe for every position I should know if the suffix is enough, so I would finish this. So as a pre-processing, for every suffix of this, I want to know how long suffix of pattern I can cover. Same thing with prefix. For every prefix I need to know, oh, here I can fit prefix of length up to 2 or up to 3 in the suffix. I think it's something like that. Is that it, or am I missing something? Then let's think how to create this. If I know, let's now, when we work with various algorithms, it's sometimes easier to just think about kind of representation of a string rather than particular example, and just fill characters whenever necessary. If we know that here we can find a prefix of this pattern of length 2, so dp for this position is 2, and then I'm looking at this character, then only in a case where those two characters are equal, I can expand. So for prefix, it will be like this. dp, I can type this so it will be easier to read. dp prefix of I is dp prefix of I minus 1, where I is positioned in the first string, plus 1 only if something like this is true. A of I is equal to, I guess, B of dp of pref of I. Right? So if dp, no, I minus 1, I'm using this already computed thing. So if I am here at I, I'm looking at the dp pref computed up to here, and then I'm comparing A of I with dp pref of, with in string B, this character. And I start with, I guess, dp pref of 0 equal to 0. Pref, let's imagine that minus 1 is just 0. And then we do this with I from 0 to n minus 1. Yeah, it seems reasonable. Stefan, you don't need to, bump your comments. Educational rounds are more educational and standard. Division 2 are more competitive. Right, we do the same with suffix. Maybe to avoid copy-pasting code, I will just reverse both strings, run some function, and reverse the return answer. All right, after I get this, what will we do? Where am I? Oh, I removed the what was previously drawn. If in this string I am looking for ABCD, then if there's B here, and this prefix, it fits two characters, it fits AB, then I'm looking for the furthest C on the right, such that I can finish this with CD. So I can, I guess, binary search here. Binary search the furthest position, such that this is at least, well, 2, the remaining suffix. So I would be able to finish the pattern of CD. The problem, again, is that in a longer string, I'm looking for a shorter string as a subsequence, and I want to maximize the distance between some two characters. Like if B is here in this subsequence and C is here, that's called width equal to 3, because the distance is 3. I need to maximize this width, maximize the maximum distance. Yeah, exactly. Coder, why are you spamming? Please don't make me ban you. Isn't chat in a little bit bigger font today? Was it always like that? When I adjusted the chat size last time, wasn't it smaller font? I think I need to, like, it's bigger. Huh. Okay, Coder, you get a ban. I mean, if you're wasting time of me and anybody else in this stream, then come on. Can I avoid binary search? I guess maybe with some 2 pointers. Maybe not even 2 pointers. I can pre-process this. For every required suffix length of this, I can just say in how long prefix of that this is found. Wait, this shouldn't be greater than or equal to 2, should it? Oh yeah, this is the smallest such suffix. All right. Yeah, then for every length of this, like 2, I need to remember position I in the first one where this begins. If this, like for this I, there is here 2, then for this J there is 3, then I need to remember this I. So for every length of suffix here in the pattern string, I will remember when it first appeared in the first string. How short, so when it was last. Damn it. First time when going from the right. That's complicated. Paste the problem link. Here you go. Yeah, somebody used the command. Get t-shirt on Google Code Jam. You can try past code gems and see yourself what score you would get. What are we doing here with palindromes? I don't know. Palindromes aren't important here. Yeah, all the streams are actually happening on YouTube at the same time. Here's the link. You can watch on YouTube if you prefer, and it's automatically saved over there. Oh, palindrome is a person. Okay. I want to see if that's the intended solution. Maximum width. For some subsequence of the string s, let pi denote the position of character ti in the string. Maximizes this. Minimum and maximum possible value of pi among all valid ps's. Okay, they do the same from left and from right, but they think about it a bit differently. They think, where can be exactly this character? So I thought with dpf prefix, for some prefix, how many characters from the pattern I can fit, and instead they think in reverse. They focus on particular character like b, and they think on what positions this can occur. So if this is string, the first string from the input, and then there is A, B, C, D. Maybe there are characters B in those positions, but I'm interested in knowing this B, that where it actually can be, so that I could finish the string and start the string on the left. To say what's the earliest position of B, I just go from the left, and if I know that this A, the first possible position is here, then for this B, its first possible position is there, and so on. So this is the leftmost. Then same thing, I go from the right. Okay, let's say C is here and D is there. Then I go from the right, and for every character I compute where is its first position from the right. I'm covering this a little bit. Right. This, assuming that this is D, this is C. Then for this D, this is its rightmost position. For C, this is the rightmost position. For this B, this is the rightmost position. And for A, maybe this is the rightmost position if this is A. And but I think that drawing is more clear if we just go from left to right and we find those leftmost positions for every character. So when earliest I can use B. Yeah, that's cool. Should we implement? I guess it's very short, easy. On the other hand, I need to run a virtual machine, but it's fine. What's up, chat? Solve today's problem C. We discussed that with the moralizer. I don't think there is nothing much more to say. He for sure explained it well. Never started the stream this late? Are you sure? Maybe. I got an email, need to read it. So what do? We read two strings. This is problem, let's call it just strings. Do we get first their lengths? Yes. NM the lengths, then strings themselves. NM read. My setup tour, the physical one or virtual one? I did a tour on my Linux setup. Regarding my room tour, I don't think that's very educational or valuable. Maybe one day. We will run something like find earliest, and then we will reverse both. And run this again. What will this do? I guess it's just it returns for every position in B. Actually, I should write this down. For every position in B, find its first possible occurrence in A. If we greedily take characters from B, we use them in A. We return this of size M. For every character in B, here I will do this. For every character CH in B, I'm looking for this in string A. Well, we're not out of string A, and A of next is bad character, ++. Add this, and next ++, because we cannot repeat the character. Maybe minimized with N. No, just sometimes we will get infinities, and that's fine. Right, this is, sometimes when I don't know how to call vectors, it's just 1 and 2. And what? For every maximum, for every position, 1 of I tells me what's the earliest position, then latest is 2 of I, to actually of, damn it, that's more complicated than I thought. M minus 1 minus I, because we reverse this, and we also reversed something in A. I think it's this. Now, if I know this for this character and the next character, for me earliest, for him latest. For every character in B, not in A. It's so easy to mess this up. No need for first condition since subsequence exists? Oh, okay, thank you. I didn't know that subsequence for sure exists. Copy. Sure, I wanted to copy. 3. This is good enough for me. I'm submitting without testing on other samples. What can go wrong if I got answer equal to length of the second string? Nice. So that was lucky. But if I just printed M always, like, I would pass the first, and after that return 0. This code also would pass the first sample. The first sample wasn't very good. Have you ever used your background to solve problems? No, and that's dangerous because my background has a lot of mistakes. Already chat spotted a lot of them. Oh yeah, come on. Somebody earlier asked a question from CodeChef. Contests are about you doing problems on your own. Imagine what would happen in a contest and with its standings if now I talked about solution to a problem from an ongoing contest. How to think loud? I mean, whatever you think you can say, I guess. You can say it loud if you want. Right, so 1 done and 1 to go, assuming that it's an interesting problem. N by N. So color cells on the border black in such a way that U cells in the top row are black, R in the rightmost column. Oh, okay. I think that's annoying. We can think a little bit, but I don't care about implementing the solution here. Or maybe it's easier than I thought. I thought that this needs to be like connected component. Rating of problems I started off with. There wasn't any problem rating when I started. And when I registered on Codeforces, I already solved some problems on Polish website. If I just started with Codeforces, I would go to problem set, sort by difficulty from easiest, and I would start solving like that. If this was too easy for me, I would jump to difficulty 900. That's it. All right, so they are saying that let's say we have a square 4 by 4, and they give us conditions like there must be 3 cells painted in the first column, here 2 cells, here 4, and here 4. Can we do this? Well, if 4, then we would paint all of that, all of this. There is 1 more missing in the first column, done. But sometimes there will be a contradiction. I think that the only common part between those first column, first row, last row are those cells. After you fix them, which of them are painted, which are not. Let's say this one is painted, this one is painted, and the other two aren't. Then from this you can figure out how many cells are missing. Let's say that here you wanted 3 cells. Then you know that the other 2 cells here, they should be painted. So if we knew that here we wanted, let's say, A painted cells, then we have this condition: A minus whether bottom left was painted and whether bottom right was painted. This is the number of cells that we want to paint here, and this needs to be interval from 0 to n minus 2. If it's in this interval, then this is possible. Similarly, we need to check if this is, let's say, B, the number of cells we want to paint in the first row. This minus 1 if this is painted, 1 if this is painted, must be in range from 0 to n minus 2. Yeah, corners are the only important thing. So iterate over corners, whether they are 0 or 1, and then do those checks. Again, it's that easy that I can just implement this. Square. I don't know input format. Test cases always NURDL. Up, down. NURDL. NURDL. Remember, NURDL. I didn't read T. What do we read? We read NURDL. NURDL. Right, then we iterate over bottom left, bottom right, top left, and top right. We have up minus the top row minus top left cell minus top right cell. I will run function check, and check should check if it's the remaining number of cells I want to print, if it's between 0 and n minus 2. Is it possible that n is 1? No, not possible. Cool. Let's say that there is answer initially true. Some remaining value. If remaining smaller than 0 or bigger than n minus 2, answer is false. I could also return from this whole function test case, but whatever. Check this, check down minus bottom left, bottom right. Left minus top left and bottom left. R minus top right, bottom right. We print yes and no, I guess. What's wrong? I guess this is wrong. The ternary operator, it has very big priority. I mean, small priority. Submit or testing on samples? I'm feeling good about this. Let's submit. No. No. No samples gang. Damn it. No samples gang, what maybe isn't the best the best strategy. Wait, no, I didn't want this. Smaller than is shift operator. I mean double smaller than. In general, this ternary operator needs to be put in brackets, otherwise it will eat kind of everything. All right, I think it's a good idea to test this on samples. I don't think you were aware about this trick, but you can copy-paste the sample tests and run for them, and this way avoid a wrong submission in the system. Well, I always got no. Why is that? What's happening in for loops? I iterate over this value 0, 1. If I just print BL, this will print 0 and then will print 1. So it's like for loop from 0 to 1. And inside here I check for the top row, bottom row, left column, right column, what's the number of remaining cells, because here I iterated over the fact that corner cells are painted or not. 1 means painted. Zero, 1 is array. This is important. It's, I think, actually some kind of list, not an array. The loop is already set to false. That's right. Okay, this check. Now, for this case, answer is initially true. I check if everything is fine. Actually, I will just return here the fact that everything is fine. 0 up to remaining and like that. And now if all those checks are true, then we return true. My logic was very, very wrong. And here we say no. Right? If for every row and column everything is fine, then yes. Right. No sample gang. Submit. Damn it. Yes, you're right. Chat already spotted the mistake. Okay, now, if you got wrong answer twice, what's the probability that you get it third time? It must be very low. I want to submit this. This must work. Easy. First time. Do you know more about brackets? It's a little bit magical, works with other things like vector. I know something with brackets, but my knowledge about C++ is like, if I do something, usually I'll know what it will do. If I want to do something, I know how to do it, and that's it. I think it's very hard to say what brackets do in general, like always. This is indeed called initializer list. It's not an array. Right, new problem. DP on trees doesn't sound interesting. Guessing the greatest. Is that some short statement problem? I want to solve this. Easier version 1600, harder is 1900. Maybe difficulties are messed up because it's an like interactive and two-part problem. Let's see. The difference is 40 versus 20 queries. Unless you tell me that this problem is very bad. Zuckerberg is grandmaster? I don't think so. Very interesting, greedy mentioned already mentioned by you or by somebody else. I think I was talking louder while I had headphones, even though I don't use them right now. Easy version is quite easy. I mean, it's not that I will solve only easy version. What is your university major? None. I'm a dropout. But I did some subjects. And different numbers. In one query, you can ask the position of the second maximum element in a subsegment from L to R. Find the position of the maximum element in the array in no more than 40 queries. Here in 20. Right. Right. Doing this in US also almost means death. I mean, I don't think US is that, strict and dangerous that you will die. It depends on the job, Same in Poland, maybe that. For a programmer, actually, it's quite easy to drop out and still be fine in a job. But if you're already going for summer internships, then, if they offer you a full-time job, just take it. There are a lot of programming software engineering companies that don't require any kind of title like bachelor's. All interactive problems solved using binary search? No, only 99% of them, not all of them. Guessing the greatest. By asking about the whole array, I can know where the maximum is. So let's say it's here. No. I find position of second maximum. Then as well I can assume that it's permutation of numbers from 1 to n. Yeah, let's say those are numbers from 1 to 7. Then I know that this is 6. I can binary search like this, like binary search here on the right from 6. This way we can know if I ask about this interval, still 6 is second maximum. If that's the case, then it means maximum is here, 7 is somewhere there. So I can separately binary search on the left and binary search on the right, and the complexity, the number of queries I ask, is like logarithm of left part plus logarithm of right part. Anybody agree with me? I mean, there is something like talent, but also I did 10 or 15 years of math, a lot of math practice. Most of my school I was doing math. I had some heads up. Nitrogen, thank you, but don't spam too much. IQ is really important, I guess. Sure, there exists talent. Like if you take 1,000 newborns and you treat them the same way, they will not be the same. Like just like there are diseases, like genetic diseases. A child can have a brain damage. Then I think it's not just binary. Like it's not that brain is damaged or not. There is some kind of range. In some bottom part of that range, we say that it's as disease. And maybe this person just has a bad, unlucky disease and the life will be hard for them. And same can happen, I guess, on the other part. And it's all non-binary. But I'm not no biology expert or neuroscience expert. And this is enough to solve an easy version, but not enough to solve the hard version. Here we have just 20 queries. We need to binary search kind of just once, or maybe at the same time for both parts. Is it useful to ask about this range? Oh, I can... Okay, easy. I can ask first about this part and about this part, and only in one of those cases 6 will be the second maximum, and continue binary searching over there. And that's it. So it's one query plus maximum of those two. Maximum of this and that. Of logarithm of L and logarithm of R. Is that it? This was way easier than the previous problem. But maybe I messed up. Binary search again? Two queries, oh yeah, two queries indeed, because I check left, right. Actually, it's one plus. By querying the left part, I can skip the querying the right part. By querying the left part, I will know if 6 is the second maximum there or not. If yes, maximum is on the left. If not, maximum is on the right. So I think this should be 1. All right. Easy peasy. Let's move on. I'm scrolling up to see some of the suggestions from before. DP on trees, as I said, doesn't seem too interesting. Sokoban, long statement. Shortest cycle. Might be too difficult. No, it's not too difficult. This is a short statement problem, something apparently related to binary numbers. There's no need to repeat your link. I just scrolled up and saw those asked previously. Palindrome, I asked you a question why you said previously. What did you say? You said that somebody already mentioned that, and I still don't know who mentioned that. You mentioned it? Somebody else? I didn't see it above in the chat. You need to query holder. Oh, right. So it's 1 plus max in the previous problem, because first we need to query the whole range to see where 6 is. Good point. Thank you, third power. That's a very interesting nickname. Oh, by me it's very nice. Okay, palindrome, sorry. Now I understand. But yeah. Anyway, I like this one for now. It's short statement, so let's do this. Link will work now. If and only if and is non-zero, so if they have common bits. Length of shortest cycle in this graph, or determine that it doesn't have any cycles. Two numbers are connected directly if and only if they have a common bit. So if one number is like this, 1, 1 and zeros, then some other number is like that, then like this, and so on. Then there are just single edges between every two consecutive numbers. I don't know why I'm doing this at the bottom. And so on, and assume that the last thing is second last thing is this, and then 1 0 0 0 0 1, like that. Here I created a cycle of size n. It's often very important to understand the problem by just seeing some example where the cycle size is non-trivial, like here linear. We are looking for the shortest cycle. Maybe we should just say that starting from some bit, if there's any number with bit on this position, I can move between bits. Like from bit I move to another bit, and so on. Should I maybe, if there is this number, I should just say that those two bits are connected, those two bits are connected, those two bits are connected. But then it seems to be a cycle of size 3. Not really this. It's like they are connected with edges of the same color. And then if there's something like that, I should say that those two bits are connected with a different color. Maybe this interpretation makes some sense. And then those two are connected with different color, and I'm looking for the shortest cycle that uses edges of distinct color, of different colors. I'm having a nice day. Thank you, Oxford. I do have a nice day. I hope you have one too. Math books? No, I don't have any recommendations. I believe that this cycle size will be at most logarithm of AI. And it will be like this case. Maybe I should iterate over what the first used edge should be. Like, I consider cases where this is the first bit and then this is the second bit. And then I want to get back from the second bit to the first bit in smallest number of steps, but it cannot be just one step. Maybe I should iterate over the first 3 bits. But then it's log cubic times n, maybe just like log cubic. But I cannot go back using the same edges, damn it. Or at least not using the same numbers. CCC problems, what is that? Is that this contest happening once every like 3 months, where contest lasts for a few hours and it's on site? That's CCC? Oh, Canadian. Okay, I thought about something completely different, but also with a lot of C's in the name. If it's Canadian Olympiad, then I saw at least one problem. If it's something else, then I don't know what it is. No. What do we do? Any ideas from people who didn't know the problem? Division 1b can be hard, and I think here it is, at least non-trivial. We can see how much time people in the top took to solve this. Some of them even skipped, well, Tle often just jumps to hard problems. 10 minutes, around 10 minutes for people in the top, then I'm not embarrassed. Your first idea should work. Make graph with 64 nodes and different colored edges. But how to find such cycle? If I make this graph on 64 nodes, and there are, let's say it's 64, and let's say those are connected with edges, this, and that, everything here, then I don't know how to use this. Here I believe there is no cycle. There will be one if I connect those two as well. Yeah, it should be a different color, maybe white. Oh, I don't need to track the full row, the full mask of colors used so far, just the last one. Right. So if I start from there, and I keep going, and I traverse yellow, then I, let's say, traverse green, I don't need to remember that I first traversed yellow. Just I don't want to get back. This will work for finding the shortest. So just let's remember that I started from here, this is the start, and then let's just remember the last edge or the last color. I think we're not just, we are forbidden to do this. Wait, can there be two equal numbers? But I don't want cycle of size 2. So what if is this valid? Something like 1 1 0 0 0 0 1 0 1 0. From 1 I get here, from this there, from this there. Is this allowed? It seems so. And then let's say 1 1 1 0 0 0. Is this a cycle of size 4? Or not? So those two are connected, those two are connected, those two are connected, and this is connected with that. So I am allowed to traverse twice the same bit. Okay, so we need to know that this is the start. I need to know that I'm right now in node, let's say V, and I need to know this color of the last edge. I have cycle of size 3, do I? I do, because of this. This suggests that, oh, if there are 3 numbers with bit on the same position, then the answer is 3. For every position I can count once. If it's at least 3, then output 3, otherwise n is small. Otherwise, actually, I think n is at most twice log of 10 to 18. If at most 2 occurrences on every position, maybe even smaller than that. Or answer is 3. And that's indeed 120. Nice. It's a good observation. And what do we do now? Now we are looking for, I guess now we can, for n up to 120, we can forget about bits and just try to find shortest cycle in small graph. And for this, I can have, like, I guess dp of start, previous previous node and current node. Where I know that I started from this, a moment ago I was here, now there, now from current I move to everywhere other than previous. And if I end up here, oh, also int, this is minimal possible cycle size. Either that, or maybe this can be Boolean value, and this will be the size. But then it's n4th anyway. This can be the first dimension, so I wouldn't have n4th space complexity. Would you use these joint sets to detect cycles? No, because we want the smallest cycle. Win reply again on Thursday? I hope so. I can use a MacBook Pro. How did we arrive at the conclusion that if n, then this? Because if on some position there are at least 3 ones, then all those 3 numbers are connected with each other. Consider those 3 numbers. Because they have ones on this position, then there is edge between every 2 of those 3 numbers. So they form a cycle of size 3. Just do BFS. Oh, right. If you have a graph, no. Maybe? If there is some cycle, shortest cycle, sometimes when there is that easy graph problem, I still need to think. I'm not fluent with graphs. I guess that there isn't any edge like that, because then cycle would be shorter. So shortest path till here is that, until here is this, and then one of them gets that. So always when we see that there is connection between 2 edges, and each of them, they already have some distance, like this has distance 2 from the start, this has distance 3 from the start, they are connected. So 2 plus 3 plus 1 is a possible cycle length. And then this dp is unnecessary. The complexity seems to be for every starting vertex go through the whole graph. So that's the number of edges, and the number of edges is limited to n squared. Maybe this is a little bit smaller, because if there are a lot of edges, it also means there are a lot of positions. I think that this m is actually limited by logarithm of 10 to 18 as well. BFS will not guarantee the smallest. If there is some, if this yellow thing, if this white thing is the smallest cycle, and we run BFS from this vertex, then for this guy, for sure, we know something like that. The shortest path until here will go through that. It's not that it will go like that. There cannot be any other edge, because the white cycle wouldn't actually be shortest. For this, that's the shortest thing. And then one of those 2 edges will be considered first. Let's assume without loss of generality, like this, and then eventually we will consider this edge. I think it's fine. You have at most 1 edge for every bit. Yeah, indeed. This is what I wanted to use. Right. And numbers, this. No, not make dir. It's copy templates to edge bits. I think that the stream will end just after this problem, because earlier I already talked for almost an hour with Demoralizer, so this stream will not be very long. I need to add this to my templates. Not ints, longs. And what do we do? Can they be 0? Well, I guess here as well I can do that. Then go through all the edges. No, I don't really want this. This is very artificial condition. I will count bits on each of 60 positions. If x and if this bit is on, count bits I++. If there are at least 3 of them, then we print 3. And otherwise assert that n is small. This is quite dangerous. During a contest I wouldn't submit with this assert, but now that I'm practicing, it's fine. It only can help me. During a contest I would be scared that maybe actually it's up to 122 or something like that. Maybe I miscalculated, it should be up to 180. But during practice it's better to check your claims and maybe get runtime error. Then you would stop and think, was this indeed a proper assert to put there? For all pairs, if their end is non-empty, put edges in both directions. Now start BFS from every vertex. We are looking for the shortest. If shortest is initially in some kind of infinity, at the end we print this. Or maybe if shortest is still infinity, do we print -1? Yes, if no cycles, output -1. Fine. For every start of BFS, run BFS. And I think I will need for every vertex its distance from the start and kind of like parent node. Distance from the start, distant and parent, let's call it. Or just, well, separately distance and parent. Distance for start is 0. There is some queue with just a start, and let's go. If not visited, distance of B is distance of A+1, and parent of B is A. And here's the trick. Otherwise, this is, like in my drawing, a possible connection between this vertex with length 3 and this vertex with length 2. But I don't want to consider this for every edge. Like, this vertex has distance 1 from the start. This is the start. This vertex has 2. But it's not that they are connected, so there is cycle of length 2 plus 1 plus 1, because those two are not separate. I need to check if one is the parent of the other. And like here, those two are not in relation parent-child, this and that, so I should take their lengths. And for those two, actually, I should take your distance plus your distance plus 1. Else if B is different than parent of A. If they are parent-child, it will enter if right. I didn't get your question, Gupta. I cannot use A. Oh, because that's the input. Input, let's call in. Why the plus 1? The edge between them. That's this thing. For example, in this graph, this one has distance 2 from the start, this one has distance 3 from the start, and length of the cycle is 2 plus 3 plus 1. Else if statement, I described it here, where I said why we need to check this. I can summarize later, but of course, no sample gang. Let's get the, once again, 0 defs, just first submission, shortest cycle. You see, no wrong answers here on this page. Okay, that's the first one. Do I assign a parent? Yes, I do. Maybe I'm parent of A? No. I do not update Q. You're correct. Yes, thank you. Like this? I think so. All right. It was sad to get this very first wrong answer of a day, but here we go. There was no way to avoid it. Oh. Assert failed? I think that assert failed. And there's an easy way to check. I can just submit with another thing here. I can say if n is greater than 120, then infinite while loop. Stream elements messages should use pre-increment. I guess so. Yeah, you're right. I am using pre-increment usually. Not always though. I'm not really consistent. I'm surprised. Can there be 0 in the input? Yes, there can be 0 in the input. I think we need to skip zeros. Yeah. Right. Repeat something n times, create long x, read it. If 0, then skip. Otherwise, let's take care of it, count the bits, and here assert.n is that. So not only when all input are 0, when a lot of them are 0. Right now, maybe I had like 100 valid positive values, but also 100,000 extra zeros. The number of non-zeros here should be up to 120. And also, if I didn't put an assert, I would get time limit exceeded, possibly, for a lot of zeros. My complexity was of like, well, n squared for a lot of zeros. Or maybe not, because actually it was because of this. BFS itself is fast because started from 0, it would do nothing. So if I created this globally, it would be alright, and just cleared it smartly here. If complexity of BFS was of the number of used vertices and edges, it would be fast enough. Anyway, I'm very happy that I put an assert, so I could now understand my mistake. Easy. All right. One last thing is that I will reiterate over what happened with this graph thing. You can find shortest cycle in a graph in n squared. Shortest, not just any, shortest. By starting, because you know this, if there is some shortest cycle out there, it's some subgraph of the whole thing, then if you run, and also there are some other edges, maybe there are also much longer cycles. This is possible. But this is shortest cycle. Then if you start BFS from one of its vertices, then for those vertices along the cycle, you will compute shortest distance from the start. And eventually, exactly at the opposite of the start on the cycle, two vertices will meet. One of them knows the distance of this part of the cycle, the other knows the distance of this part of the cycle. So they know that 2 plus 2 plus 1 is cycle size. I consider this to be a cycle size. So I do that for every pair of adjacent vertices with one exception. If for some starting vertex, like the distance from u is 1, 2, 3, I cannot just take this pair and say that I see here a cycle of size 2 plus 3 plus 1. Like here I saw 2 plus 2 plus 1. No, this is bad. They cannot be in relation parent-child in BFS. So if one saw the other and this 2, it put here a 3, then I remember parent of this 3 is this 2, so I then don't consider this to be the answer. How do we get twice log of n condition? I know that if in some position, on some bit, there are at least 3 ones, then it gives me 3 numbers that are all connected to each other, so there is a cycle of size 3. Yeah, this was a unit graph, where every weight is just of length 1. Indeed, the professional official name for this is pigeonhole principle, but I would just call it common sense. What's happening over here? I've just finished solving some Codeforces problem. As you can see, first try, accepted. No issues there. And indeed, modulo 3, that's 0 try, not really. Modulo 2, I guess, 0 wrong answers. Or maybe 0 wrong submissions in total, because there is 1 wrong answer and 1 random error. I don't really know why there's a name for pigeonhole principle. Like, if you have 10 items and 9 boxes, that, yeah, of course you will not fit everything in different boxes. Yes, Gupta, exactly. And if there are 2 numbers per bit, then the number of numbers in total is twice the number of bits, twice 60. And I will sadden some of you, but I'm ending the stream here. Mainly because before the stream I talked with Demoralizer about Codeforces round. post again on YouTube the moralizer. Here you can, I will post in the chat the link to this. I was there. You can watch us discussing hard problems from, am I somewhere? Yes. Oh, you see this guy? That's me. How do I share this? Here. Oh no, there are some dislikes. Post Codeforces stream with the moralizer. You can watch that if you want, at least the second part, because I was there. Thank you everybody for watching. Lots of problems can be solved with that idea considering some groups of items. Yes, but also it's like saying that actually I don't have any reasonable comparison. It's obvious. You don't need a name for that. Like if you said that if we notice that x and y, then in particular y. Let's call that Camille rule or end rule. Just like that. Dislikers didn't understand. Dislikers tested their code on samples. Win Google Google competitions this year. That's such a polite message. Can you win Google competitions this year? Thank you. I would for sure hope so, and thank you. Right. So again, thanks for watching. Check out the Discord server, and bye. 21 pigeons to 10 hulls. Yeah, but you can also figure out what will happen there. Hashcode finals, indeed. That's easier than CodeGem. We'll see. Bye.